Okay guys, I got a little update on the power supply. Actually, it's kind of a big update. When we last left off, we had the transformer wasn't mounted, and now we've got a transformer mounted, and you can see we've got plates bent into shape and everything, and the taps are all wired in and everything, and the tap select bank is in there. They're relays. Tap select bank, you know, I gotta be a little highfalutin here just for giggles. All the wiring for the tap select is here, and we survived first turn on, which is beautiful. But I did make a mistake. I put the tap selects in the wrong configuration. So what it's doing is it's putting a full 100 volts onto the reservoir capacitor instead of 6 volts. So actually it should be, no, actually it should be closer to 14, because it's 10 volts, it's rectified. It should be about 14 volts. So what I need to do is I need to pull the taps out, or not the taps, the tap jumpers, and I need to flip the green and the white and the green and the black. So all those need to trade spaces, and then that will configure the power supply for proper configuration, and then we'll have 6 volts on the reservoir instead of 100. But right now it's got 100 volts on the reservoir, and you don't want to touch that. That's no. That's God, what is that? It's like 20,000 microfarad, something like that, at 100 volts. You don't want to touch that. That's not a good idea. So what we did prove, though, is that it'll survive a switch on with an empty reservoir. So the rectifier survived the I surge. We also verified that there's 0 terminal voltage. So the pass regulator survived. It should. These transistors are rated for 450 volts. So they didn't break down, which is very nice. And really they shouldn't break down, because they're only looking into 1,000 ohm load. So that's not really a problem for them. Although if they wanted to go up torpedo, they certainly could do that. But we've got the transformer wired in, and all those taps are wired in. Looks pretty nice. I think it looks pretty good. This is pretty nice for, and you look at the wire tying. It's pretty nice for a prototype. So when it's finished off for real, we'll shorten up the leads properly and, you know, turn it into a real product at that point. But at the moment, this is a prototype, and you see I got my terminal marker strips down there. Of course, I guess we don't really need it here, but these are important for drawing purposes. So whoever's servicing the item can figure out where they're at. Of course, you could just make a drawing, but it's nice to have these mil-spec markers in there. And they're only like, they're like $3 or $4 a piece, so why not, right? Okay, well, she's off and the reservoir caps got to drain. So we did prove that it'll survive a turn on with the cap totally empty, which is really good. I didn't know it was going to do that. And it was good that we didn't have the control board in here, because if we had the control board in here, then the pass regulator would have been trying to regulate a full 0 to 100 volts, and it's not designed for that. It's only designed to handle about 20 volts at a time. So we're lucky that we didn't destroy anything. Not that these transistors are terribly expensive, but being they're $6 a piece, it's still not fun to have to repair them and then try and figure out what the hell I did wrong. So that's it. More to come. We'll start talking about the control boards and the actual circuit itself and how it's implemented. That is, if I can do it correctly. That will be another challenge. So that's it for now, guys. Hope you're finding some interest in power supplies, or at least, you know, we can talk more about power supplies in the future. The meters are missing right now because I'm having measurement error issues with them. And we have a boatload of taps here. 3 for the supply, and then the rest auxiliary taps are for meters and accessory things. Okay, so that's really it for now.